In this episode, I want to introduce the MicroVAX 3100 family, especially the MicroVAX 3100 Model 10, and show you the machine from the inside, from the outside, and install that machine in my cluster. Hello viewers and friends of fast-spoken incorrect English with a German accent. Welcome back to another episode. And this is another show and tell episode, and this time about the MicroVAX 3100, as I said in the last video, and this time especially about the MicroVAX 3100 Model 10 you can see here in front of me, with a nice VT510 on the top. I've got a few MicroVAX 3100s. One here, also on the left and also one on the right, and I will tell you more about the different MicroVAX 3100s in that video, and showed you the machine on the left, and also talked about MicroVAX 700 in the last episode, there will come more videos about this series, because this video is mainly about the MicroVAX 700 Model 10. But first, show you in short the MicroVAX 3100 Model 40. This is the Model 30 in a bigger chassis. So the Model 30 is in the chassis in a size like this machine. This is the bigger Model 40. You have space for more discs and also a bit more powerful power supply. And I've introduced this in the last video, and I will make a dedicated video about this machine soon, and will also show you a comparison between this machine and what's different to that machine, because there is a nice difference between these two machines. The machine on the left is, look inside, quite more modern than the old Model 10. Then second here on the right is more or less only the chassis with the board inside. This is MicroVAX. MicroVAX is a VAXstation 300 Model 38 or Model M38. You can see it here. So this is my first VAXstation, and I was looking a long time for VAXstation 3100, because the VAXstation 3100 in some generations is capable to run Ultrix with graphic. This is not capable for that. This is also another thing. The other thing is this machine is not working, so it loops while it's running test B, and test B is the memory test, and I think this is a voltage issue. It's caused maybe by old decoupling capacitors, but this is definitely something which needs further investigation. So I will have a look on the electronics of that machine in detail, and I hope I am able to repair that machine so that the machine is running again. And the reason why Ultrix is not running is because this is the machine with the SPX graphics card. So there are two different graphic cards available for that machine. One is GPX, I think, and the other is SPX. And SPX is the faster, newer one, but not supported by Ultrix. But maybe I can remove the SPX card, and then the machine will run only monochrome, and then maybe Ultrix will run. But this is something I have to check. But first of all, I need that this machine is running, and after that I can check different things with graphic cards and Ultrix and so on. But if you want to know more about the VAXstation 3100 and different VAXstation 3100s on the channel of Digital Diggings, you will find some interesting videos about these machines, also about Ultrix, and I will link, I think it's 3 videos, I will link all 3 videos down below, maybe 4, maybe 2, I don't know, but you will see the links down in the video description. And now, to that machine, so the machine of that episode, and this is the MicroVAX 700 Model 10, and it's my second MicroVAX 700 Model 10, but this machine is working, but my other machine has a specific damage which often occurs on that machine. So we'll talk about later when we have a look inside. I will show you what's the issue, or often an issue with these machines. This machine, the MicroVAX 700 Model 10, is a special machine for me personally, because when I was 14, got first in touch with VAX machines, and my first touch with VAX was the MicroVAX 700 Model 10. So not this particular machine, but this module is the first VAX I've ever saw, and therefore I really wanted a MicroVAX 3100 Model 10, a running MicroVAX 3110. And I've got this machine and also the VAXstation and also these, here this storage expander in the size of, or chassis of a MicroVAX 2000 or VAXstation 2000 from a viewer named Holger. And he wrote me an email and I drove in the far east of Germany and picked these machines up a few weeks ago. So many thanks to Holger for the machines and also the really nice talk about VMS, VAX, VMS and science, science in general, education system in Germany, and also several other things. We had a really nice chat, and also we are still in contact via email. We've got also another nice workstation from him. So special thanks to Holger. If you see that video, but I think you will see that video. And now I will show you the MicroVAX 3100 from the outside and also from the inside, like the other show and tell videos of my channel. Then I will set it up as satellite in my cluster. So inside that machine there is a hard disk. You can see maybe here on the VT510 DK300 there is an OpenVMS installed, but this is from the previous owner, also the owner before Holger had the machine. I won't show you any details about the previous owner, therefore I will use it as a satellite, and later on, after I've extracted the licenses of that machine, I will also delete the installed OpenVMS installation. I've recorded inside and outside tour of such a machine before, I think 2 years ago, about my VAX server 3100. You will find 2 videos about the VAX server 3100, and the VAX server 3100 is the non-time sharing version of that machine. So in general it's the same machine, only with a different ROM. But my VAX server 3100 is not running, so this is also my first running machine of that kind. And also in the meantime I've learned a lot of more about that machine, so I can tell you a lot of more things when we see that machine from the inside, and also the running machine, but I've mentioned it several times in that video. First of all, some basic facts about that machine. The MicroVAX 3100 Model 10 and also the bigger Model 20 are the first model or generation of MicroVAX 3100s. The codename was Teammate 2, and the Model 20 is that machine in that case, so the bigger case. This is the only difference between the two machines. It was released in July 1989, and it was the successor of the MicroVAX 2000 or the VAXstation 2000 with the codename Teammate. So this is Teammate 2. The processor in that machine is, I can't see it anymore. At the top, as it was written, it's KA-41A. This is a CVAX machine, and it has a speed of around 2.4 VUP, so VAX unit of performance. This is basically 2.4 MIPS, more or less, because there's a nice discussion about the topic if MIPS is the same like VUP or not. And the processor clock is 11.1 megahertz. So these are the basic facts, and now I will show you the outside, but first of all I have to remove the terminal and also switch the machine off, and then I will show you the machine from the outside. That's the outside. I've removed the terminal, so it's now over here. The keyboard also there on the right. The front, it's quite unspectacular. There's just a panel here. Maybe there are devices behind that panel, so the CD drive, that machine on the right, the Model 40, there was CD drive here, but I've removed it because I have to clean it, but nothing is behind the panel here on that machine. Some machines are equipped with a floppy drive, but I think this is more or less a VAXstation thing, so I don't really know. Maybe there are also MicroVAXs with floppies, but I don't know. But this is quite unspectacular. This is also a metal case, not like here the later machines, like the 4000, this is plastic. The older machines are made of metal. So let's turn it around because the back is more interesting. This is the back of the machine, and here power connector and switch. So the switch is on the back. Later on the 4000 series, you can see the switch is on the front. And yeah, here let's go through all the connectors and all that stuff. These are status LEDs. You can see it. You can see it. Here are status LEDs. Eight LEDs. They show up the current test and the current status of the machine. So when there's some kind of error, you can see which test fails. This is the brake enable switch. I don't know if there's any usage for it. In the handbook is written brake enable is only used by the DEC field servers. So I don't know. I've never used the brake enable switch. I think you can change something for thermal, but I don't know what. Maybe when you know the purpose of the brake enable switch, you can write it down in the comments below. This is a port for a modem, so you can use the dial-up connection, and there are the 3 terminal connectors. And yeah, this is a time-sharing machine, but also the VAX server, which is not a time-sharing machine, has these 3 connectors, but you can connect up to 3 terminals directly to the machine. Here, this is the halt button. When you push that button, you will see the dead sergeant again, so it will halt the current machine. You can see here on the that's happened because after boot, the machine wants to boot from the Ethernet or from the network, and at the moment the cluster is not running and it does not find the boot server. And when you push the halt button, the current whatever is running is halted, and you will see it will come back to the dead sergeant here. Then we have network, so 10-base-2 and 10-base-5, and the switch to switch between the AOI and BNC connectors, so we can use only one of them. So on the top here this is the external SCSI connector. The machine has 2 SCSI buses. We will see the quite strange SCSI design later when we have a look on the inside of the machine. And here these are 2 connectors for synchronous and asynchronous communication. This one here, this is a synchronous communication port. I've never used it. Don't know. There is some kind of module available. It's called DHS32 option module, and it can run RS422, RS423, or RS232. But I don't know. And here this is for asynchronous communication, so terminals 4 to 11. I think I have a box which can be connected to that port, but I do not have the cable for it. But as a standard connector, maybe I can build one of these cables, but you can here connect more terminals. I think this is the reason, this is the purpose of that port, because this is 4 to 11, here this is 1, 2, 3, this is the asynchronous connection. Yeah, this is these are the connectors, and this is the outside of the machine. And now let's open it and take it apart. Yeah, this is the inside. I've opened the case, and you can see here there is the hard drive. What's the hard drive? DKA300 with the previous installed OpenVMS, and this is an R-Thate 23-E, so this is an original DEC hard drive. On the left, this is a power supply. This is not the original power supply. The original power supply from that machine is broken. I still have 2 power supplies to repair, but I think it's quite easy repair to. It's not the hardest repair, because at least one of these 2 power supplies have only a minor damage. The other one maybe, I don't know, but I only need at the moment one more for the VAXstation, because the VAXstation 300 has the same power supply. And here there's a board, and this is called the distribution module. Here are the asynchronous and synchronous port, and also the SCSI connector. So the external SCSI connector has a cable, it goes to here. This is just a standard, we can remove it because we have to remove it for later. This was the part of the connector. This is bad because I have this. I have to repair it before I will put it back together, but I think the plastic broke. This is not the old plastic, 35 or more years old, maybe broke. I think it's repairable, but that's just something I will do. Well, put it back together. But this is, you can see, just a normal 50-pin SCSI. The weird thing is that connector here. This is a DEC proprietary. Yeah, I'll remove it. I won't lose the connection over here because maybe I will destroy it again. This is some kind of ring cable, and think these are 100 pins, so 50 on the top, 50 on the bottom, and the SCSI bus is a ring inside, and here are the terminators, because the machine has two SCSI buses, bus A and B, and I think, let's have a look, one of these is bus A, I think this is bus A, and this is bus B. The only purpose, I think, is just to avoid a special termination, but I don't know why they choose this strange cable, or yeah, because this is different, the two different buses. And this is nearly everything on that top board, so we will remove this metal board here. This is one piece. We can only loose some screws, and I can remove the whole thing on the top, and then we will see the system board. There's also a system board here on the right. You can see it a bit, but why there is a second system board, I will tell you later. Because I told you before, there are some issues with that machines, and this is the reason why there is a second system board. And this is the cable. It goes down to the system board. This. Also, we don't know these. Here you can see two screws, and here there's another screw. Forget it. Another screw over here. And these screws, there's a spring inside, and here on the right there are three completely different screws. I hope. Really don't know why they choose that design. And these screws you can remove completely, and you do not have to, but when you don't remove them completely, it's a bit hard to put the metal board back inside later. So now you can just, there's also forgot one. Here's another screw. So now you can just remove the whole thing, and now we will see the system board. I'll remove the cable as well for a better view. This is the system board. And now we'll show you a closer look on the system board. And it's also called CPU module in the service manual. And here, this board over here is additional memory. I will not remove the additional memory, but you can, these are the connectors here on the other board, you can place additional memory, because here this is only 4 megabyte of memory, and more 4 megabyte I think it's enough to run as a satellite, but it's not much memory for your OpenVMS versions. I think you have to use at least of VMS. It's called VMF then, VMS 5.2 for that machine, but I'm not quite sure at the moment. So one thing on the memory, you can count the memory here. These are the memory modules, and as each module stores 1 megabit. So this is a module for 1 bit, and you can count them, and then you will count these are 36 modules. And for 4 megabytes, you would only need 32. So these are not storing 8-bit, they are storing 9-bit, so it's a parity. There's parity. It's not error correction, but it's error detection. This is the parity memory. And also the additional module has also this capable of parity. Here let's have a look on the board. And the other parts here are this is power connection. These are here's a connector for the option board. I really don't know what this board is doing. My other VAXstation has a board connected to that it's called combo connectors, but I really don't know what they are doing. But I have a board in my other machine for that connector. So I have something I have to find. I have to research, because I know that I have that board, but I forgot it until I see the connectors now on the open machine. Yes, let's go on. Here, some kind of network interface. These are the ROMs. This is upper word, lower word. This is some kind of LSI chip. So it's in the handbook is written CVMTC gate array. And on that board, I will talk about later on that board, there was released some magic smoke in that area. So maybe the board on the left is broken. This is the ROM for the SCSI, and this is the RAM for the SCSI connection, and the processor is here. This is the VAX processor, and this is the floating point unit for the processor. Yeah, so the processor is way smaller than that thing over here. This is the SCSI controller, and this is also some SCSI stuff, and these are the main things. Yeah. Interestingly, and here these are the tri-state for the bus. So let's switch to that board, because this is easier to explain here. And that board here, the processor is here. Then here are the tri-states for the bus, and here is the memory, and here goes the connection to the external memory, and here on top to the ROM. And the reason why I am so happy about that machine, you can see I think this is a bit newer generation, because the board is green, is here, down here. Yeah, there was a battery. The battery was here, so the battery is gone now. It's good that the battery is gone, because these batteries are leaking, and I call it the sin of DEC. And I really don't know why they choose these batteries, these nickel-cadmium batteries, because there is they leaks, and this is a lye, not an acid, and the lye goes everywhere, and it destroys the board in that area over here. And this is a 6-layer board, so you have 2 logic layers on the top, 2 logic layers on the bottom, and between these 2 layers, between these 4 layers are 2 layers for the power distribution, so 1 for ground, 1 for 5 volt, and it can destroy also the layers, second or the third or the fourth layer. So this is when this damage is very, very hard to repair. And I've tried it here on that board. Maybe I will make a dedicated video about that, so you can see it. I've made a lot of new traces here, and also on the other side. So I've desoldered that whole part and soldered everything in, but it won't start the machine at the moment. The machine won't load the things stored on the ROM over here. But I think this has something to do with the damage in that part. Maybe I have to remove that chip as well and check all the traces on that part. But normally the power supply has a signal that the power is okay, and when the signal is there, the machine starts to read out the ROM, and this is not happening. But this is not happening down here. This is a bit of memory and a bit of, I think these chips, these are hex NANDs, and these are hex NANDs, these are the tri-states, and these are other 7400 chips, but this is only logic down here, and I think this is controls only because the traces go to that connected to the memory connector here, connects only the switching between the external and internal memory. It's nothing to do with loading stuff from the ROM. But this is something I have to check, because this is the board of the VAX server 3100, and I hope that I will bring that board back to life again. But you can at the moment I have still one running machine, and this is the machine here in front of me, and I'm very happy that this machine is running. So now I will put everything back together and also repair the damage of the connector, and also found out what this board here is, because I want to know what this board is doing. But I will do all this stuff off camera, and the next step I will turn on all the cluster machines, but it takes a while, and install that machine as a satellite in the cluster. So I've put everything back together, and I've also repaired the cable. It was just the plastic part came out of the connector, but it was easy to put it back, so nothing is broken. Yeah, and also I found the board. Here is the board which is not installed in that machine because it wasn't in that machine, but I've got the board from my other MicroVAX 3100 Model 10. Yeah, and yeah, this is the board, and the board is here's the number. It's a bit weird written on it, but it's 54-18905-01, and this is some kind of communication, synchronous, something else controller. It's also here written on the C1 L1 combo controller written on it. It has something to do with the asynchronous and asynchronous communication, but I've never used that communication ports at the moment or until now. So at the moment I do not really know what this board is doing, but I have that board and I can install that board also in that machine. But maybe I bring the other MicroVAX 3100 back to life and then I will install that board in that machine because this board belongs to that machine. And maybe you know more about these controllers and the asynchronous and synchronous communication ports of the MicroVAX 3100. So write it down in the comments. It would be really interesting to know more or to learn more about that thing. So now back to the machine, and now first the terminal is not on. That machine here, you can see it's booted. The MicroVAX 3100 Model 40 is booted into the cluster. The cluster is running. Now it's also a bit louder than before. This terminal, sometimes you have to turn on it twice. Now with the nice message from the previous owner. Yeah, this is the message. And now turn on the machine and we will see the startup sequence. I hope that you will see it. Hope I choose the right, yeah, there's it. That should be the right input. So if you can see the processor here, KA41-A, version 1.4, and now it runs several tests. And we will also see some errors, but these errors are not very important or does not affect the do not affect the possibility of that machine to run. So it takes a while, and because it's not at the moment it's not in the cluster, so I have to write down the MAC address and go to the cluster config. Yeah, these are the errors, and E is the clock. This is caused by the missing battery, so as we'll say, it does not know the time. D is, I don't know, I think something else about that. I don't know, I have to look up. C is a serial controller. Maybe I saw these errors a lot of MicroVAX 3100s, but maybe it has something to do with an error over there. And 6 is the SCSI bus. When there is no device in the SCSI bus, then there is an error. This is SCSI bus B. And the other SCSI bus, there is a device. This is this DKA 300. When we hit enter, it tries to boot from the network, but at the moment it won't boot because the boot server does not know that machine. So let's write down the MAC address on a piece of paper. And then we go to another terminal here, my favorite terminal, the VT420, and we are in cluster config at the machine DB3, which is the boot server, and we want to add a node to the cluster. The node name will be FRR2. Oh yeah, I have to look. It's 10.34. Plan. The network is a bit too big or become big. This is the reason why I have listed a table where all the addresses and for new machines are written in. Is satellite, yes. Then it checks if the satellite exists, yes. It's the disk. then it's sys34 because on that machine I have this naming scheme or a scheme of folders is used by the previous owner of that machine. So it's for satellites. The sys drive is always sys. I can also write it capital letters, but I think it's so write it capital letters looks better. Is sys and then the number of the DECnet address, the second part of the DECnet address, in this case 34. So then you know the folder sys 34 is the system for the DECnet address point 34. No workstation software because this is just a console, a terminal machine, and now it creates all the folders in these, the system files, copies the system files to the folder. It's no disk server. Now it's created, and now I have to enter the network address. Hope that's correct. Let's check it. Yeah, that's correct. Enter. That's okay, just for testing purpose. No local disk. There's one local disk, but we won't use it. So we page and swap over the network to the system disk of the big VAX of the cluster. So the VAX server 4000 model 200, but for testing purpose it's okay. Later on, we should use local disk for paging and swapping, but I can change that later. And now it creates a page file, it's a swap file. So, and now it is there, and because there was a boot loop on that machine, it starts to boot from the cluster as soon as that time where the cluster database was updated and the network database. So it loads OpenVMS via DECnet from the cluster, and now it will boot, and it will take some time. So I will enter date and time. Today is the 3rd of June 2026, and what time is it? It's 6 minutes after 10 p.m. So it takes a while because it also will restart several times because it runs autogen and all that stuff. So I will see. We'll turn the camera back on when the system is. When I'm able to log in. The system has done all this first startup procedures and all that stuff. But you can see now here it's now a member of VAXcluster and also the cluster configuration. Here there is the machine FAR2 and FAR1 is the other machine. Now it's booted, it runs all the autogen, all the first startup things. Took about 15 minutes or something like that, and now I'm logged in, but you can see there's no license active because I have to activate the license on the current boot server, or I have to add a license to the boot server and include the machine, the specific node, and that's not the case. But I can log in on the operator's console with the system account just to do some maintenance. So this is working, and now here are two machines. That machine had the license, so I have made the license, but this machine is something for one of the next videos. We'll show you that machine in detail. And that's also the end of the video, and I hope you found it interesting, and see you in the next episode. And at the end, special thanks again to Holger for the two machines, because this is the first time a viewer contacted me and gave me two machines, and I've got these machines for free. So he does not want any money for the machines, and that's quite rare these days that someone gave machines away for free, just to for a new home to a nice collector, so they can be in the cluster. And at the moment I've started a lot of machines. You can see there are a lot of machines are running at the moment in the cluster, so the cluster is growing, and there are more machines in the storage, so I can grow that whole thing. second time. Thanks for watching and see you the next time.